Hello guys, welcome to Inside Electronics. So in today's episode, let's talk about a really simple electronic device that is found in almost everywhere where you have an internet connection. And they are ADSL splitters. Even though these simple little devices are almost everywhere where you have an internet connection, most of the people don't even know why we need an ADSL splitter. All they actually know, I asked a lot of my friends, do you know why we need an ADSL splitter? And they all said, you have a telephone, you have a modem, and you only have one incoming line. So you need something to split, you need something to connect both of them together, and we use an ADSL splitter. That is the answer they all gave me. And that, most of the people don't even know why we need an ADSL splitter or how they work, so what is the actual benefit of using an ADSL splitter. And some people even told me it is for protection of devices. It's for protecting the modem and the phone from lightning and things. And I certainly believe that is because the cover of these things actually misguide you to thinking that it can be used for protection against lightning and things like that, which is actually, can you actually trust these things for lightning protection? I certainly can't. But anyways, I'm making this video just to make people know that why we need an ADSL splitter and what is the exact thing that is happening inside them when you are connecting to internet. So I have three different splitters over here. These two are used. This one is brand new, though it is not brand new at the moment. It is bought in 2016, but still it is not used. So in that sense, it is a new old stock. So all these three are passive splitters. Now I'm talking a lot like splitters, but in fact what they really are filters. They are commonly known as splitter in China, and as they sell most of these from China, people actually calls it splitter. But what actually are these are filters, because they serve a purpose of filtering the unwanted frequencies. Now before moving on, in this video I will actually take apart all of these, and I will draw the circuit diagram for it, and I will explain it. And before that, let's talk a little bit about why we need an ADSL splitter. For that purpose, I'm going to show you guys how the actual ADSL thing works. So let me actually adjust the thing. So let me draw the telephone line. I assume you can see all this. So this is the telephone line that is coming to your home. Okay, so you have your land phone, your phone over here, and you have your computer, which is like that, and you need something to connect your computer to the telephone line, right? So we actually use a modem for that purpose. We use a modem to connect your computer to the internet, okay? And at the same time you need to connect your phone, at the same time you need your phone also to be connected to the internet. But there comes the issue. What actually happens is that your phone is designed to carry only voice. Okay, so you are only talking to another person. Some phones will allow something extras, but I'm just talking about the normal telephone. And under the ports, or let me adjust the exposure a little bit. Okay, the ports or PSTN network, the plain old telephone system or public switch telephone network, both are the same. These uses the 300 to 3.3 let me focus on it, 3.3 kilohertz frequency. The 300 to 3.3 kilohertz frequency, your voice gets modulated to anywhere between 300 to 3.3 kilohertz for it to be transmitted over your telephone line. Let's say TL line, telephone line. Okay. At the same time, your modem the device that you use to communicate your computer to the internet uses anywhere from 25 kilohertz to 1.1 megahertz of frequencies. Okay, so your phone uses frequencies that are only in the kilohertz range, which is a much lower frequency when compared to 1.1 megahertz. And the reason why it uses 1.1 megahertz is because the modem is actually an ADSL modem. Usually all the modems nowadays are ADSL modem, which ADSL stands for asynchronous digital subscriber line. Okay, let's just forget that. Synchronous digital subscriber, my handwriting is not good, subscriber line. Okay, and this thing in fact uses FDD, which stands for frequency division duplexing, for communicating between your computer and the transmission line. So how that thing works is actually it uses the 25 kilohertz to around 137 kilohertz for uplink. Okay, so your modem uses 25 kilohertz to 137 kilohertz frequencies for uplink. Uplink means transmitting data from your computer to the telephone line, and at the same time it uses 138 kilohertz to around 1.1 megahertz for downlink. And downlink means the data that is coming from your telephone line to your computer. Okay, so these are all the frequencies that are involved in your telephone line when you are connecting to internet. So your modem actually stands for, I hope you know that modem stands for modulator and demodulator, because it modulates the digital signals to analog signal so that it can be transmitted to your telephone line, and also it demodulates the analog signals back to digital signal so that your computer can understand what is coming from your line. So that is what modem stands for. Okay, so now let's see how we can connect these two devices to your telephone line. For that purpose, you can do a couple of things. I see a lot of people connecting these two together, just by twisting the wires together and connecting them straight to the telephone line. They usually use a device that looks like a splitter, but in fact that device also has two output ports and an input port. All that it does, it just connects them in parallel. It does have any internal circuits at all. So I see people using that kind of things, and when I ask them why, they actually tell me that the splitter is causing the internet speed to go down. I don't believe that anyways, and I will show you why in a minute. And the first thing is that you can connect them straight together and you won't notice any difference. Your phone will work, your modem will work, you won't notice any difference, except at some points, which I will talk about later. So the other way is to use a splitter that is in between. So your telephone line comes in to the input of the splitter, and as you can see, the splitter has two ports. Every splitter will have two ports. You can see modem, phone, modem. So you connect your phone to your phone line, your modem to the modem line. So let's draw that. Okay, let's say a splitter. Let's draw a splitter over here. This is a splitter, 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 and the line goes to your telephone. Another line goes straight to your modem. So that is how a splitter is normally connected in a broadband connection. So now let's see what happens. The PSTN networks actually carries around 60 volts DC. 60 volts DC that is used for functioning of your telephone. But your modem does not need the voltage that is coming from your transmission line, because the modem gets its own power supply, so it does not need that 60 volts. for that purpose, every modem will have an ADSL splitter transformer. This thing right here, there's an ADSL line transformer. It isolates the power lines of modem and the telephone line. That will be a video for later. So in normal cases, the splitter, the telephone line comes in like that, and inside the splitter, what happens is that, as I mentioned earlier, every splitter is actually a filter. So let's open one of these. Let's open this one and see what's inside. Okay, that is the very basic inside. That is the very simple. It has transformer, two transformers and two capacitors, an input port and two output ports. That is what's inside on almost every single splitter. Let me open this one and see the exact same thing. The only difference is that instead of using a proper transformer, they are actually using a toroidal, like a ferrite bead transformer over here. This is also a transformer. You can see 4 coils. So now let me tell you what happens. This is actually a low pass filter. Okay, a low pass filter, the LPF or a low pass filter. Okay, so what it does is, the low pass filter, as the name suggests, it passes all the low frequencies and it blocks all the high frequencies. So you can now guess what frequency it is going to pass and which frequency it is going to block. And you guessed it correct. The pass frequency is the 300 to 3.3 kilohertz frequency. So the splitter, it passes all the the 300 to 3.3 kilohertz, and it blocks all the 25 to 1.1 megahertz signals. Okay, so now you may be asking why it is blocking the 300 to 3.3 volts. It's blocking the 25 to 1.1 megahertz signals, because if it blocks it, how can you communicate? That is a question that is in your mind. I know it. Actually, what happens is that it is blocking, but it is not blocking the transmission between the modem and the transmission line. It is actually blocking the signals. It is actually blocking the 25 to 1 megahertz signals from passing it to the telephone line. Okay, so what happens is that let me draw it again over here. The splitter takes it and it divides it into 2 frequencies. Okay, so when the input signal comes, the 300 to 3 kilohertz frequency can directly pass to the phone line. Okay, and at the same time, the 25 to 1 megahertz, 25 to 1.1 megahertz signal can also pass through the splitter and go straight to the modem. There is no objection for that. But now you may be asking why it is called as filter. Then it is called filter because it blocks the frequency from here to going back to the telephone line. Okay, so what it essentially does is it blocks all the high frequency signals that are generated by the modem. It blocks all these high frequencies from getting on to your telephone line. That is what it actually blocks. Okay, so it blocks all the high frequency signals from your modem from getting into your telephone line. Because if you know what happens, if the high frequency signal gets into the way of a low frequency signal, it can actually overwhelm the low frequency signal and it distorts and it creates a lot of issues in the phone line. You're not going to see it in the modem because it's of the high frequency. It has much more power than low frequency signal. So the splitter actually helps you to protect your phone line. It is not designed to protect your modem from anything. It is actually designed, the splitter is designed to protect your phone line from all these distortions that is going to be made by your modem. That is the reason why it is known as a filter. It protects your valuable telephone. So that's the way this thing operates. It blocks all the frequencies from your modem coming back to your phone. So I hope you understood how a splitter works by the circuit and the theory behind the splitter. And now let's actually reverse engineer the splitter, and I will show you how exactly this blocking is done. So I'm going to reverse engineer. It is actually really simple. If you look closely, this is really simple circuit. There is nothing much into it. Let me open everything. Okay, this is this one. There is absolutely a lot of components inside. Okay, let me open this one also. This video is going to be a little bit longer, but I think it does not it is not an issue, because people are here for learning something new, and for learning new things it doesn't matter if it's long or short, I think. And as you can see, this brand new one also has a similar circuit of that one, and in fact all the three are the same. So let me reverse engineer the circuit and I'll be back. So now I have completely reverse engineered the circuit, and it is really simple. In fact, as I mentioned, all it has is just a couple of transformers and a couple of capacitors. And the only difference between this new one and these two old ones are these two does not have these two capacitors. On every other aspect, all the three are the exact same circuit. So let's just keep these two apart and take this one. So as I mentioned in the beginning, these are known as passive filters. These are passive filters because you can see there is no active components involved. There is no transistor, not a diode or anything. There is no active electronics involved, and these are hence known as passive filters. And these, by the way, these are not transformers. In fact, they are just inductors that are wound in the form of a transformer, and they are acting more like a common mode choke, like the common mode choke that you find in an SMPS. This one for the line filtering. Not for line filtering, it's also for preventing the high frequency from getting back to the IC line. So these coils are much similar in operation to the common mode choke that you find in an SMPS. By the way, you can watch the video about this one by clicking the I button up there. So all it does is, this is a circuit. Let me focus on that. So for the people who are telling me that the splitter, the passive filter, is what causing the internet speed to get reduced, just look at the circuit. The modem is connected straight to the telephone line. There is not even a single resistor that is in line with your modem and your telephone line. So for the people who are telling me that this is causing your drop in speed, this is the answer for you. And the only problem that this can cause is, if the splitter is bad, it can cause problems with your phone. Because if you take a look, these are actually two inductors in series for each line. On every line you are having two inductors, and I don't have an LCR meter to measure the inductance of this thing, but it will be quite high because of the frequency that it is designed to be blocked. This, and also it's because it's having this ferrite based winding, the inductance is going to be much higher. And also it is an LC, this inductor capacitor LC filter, which is normally used for high frequency applications. So what happens is that the telephone line carries the high frequency and the low frequencies. The high frequency can go straight to your modem, it will not affect anything else. The low frequencies can actually pass through this line, because as I mentioned, this is a low pass filter. It is designed to pass the 300 to 3.3 kilohertz frequency. So until the frequency is below 300 kilohertz, it is going to pass straight through without any obstruction at all. But as the frequency goes up from 300, this circuit kicks into action. It opposes that frequencies from getting into the phone line, and that way, if the high frequency signal, if by any means it goes into it, there are two stages of filters, so it's going to effectively block the high frequency from getting into your telephone line. And after all this, your high frequency and low frequency can actually coexist in your telephone line without any issue, because of the presence of the filter and other things. So that is all about an ADSL splitter. Now I hope this video solves the mystery of why we need an ADSL splitter. And also I want to tell you something. This thing tell you that it is lightning proof, and from the circuit you can guess there is no protection at all. Your modem is straight connected straight to a telephone line, it will get blasted off, and the frequency, the power of lightning can easily burn through all these lacquer and everything. It just completely obliterates whatever that is in between its path. So you cannot trust this for the lightning protection at all. So I hope that everything is done. And by the way, these only cost you around 100 to 150 rupees, and there are some even cheaper options that are available for like 40 rupees, that is less than $1. But I cannot guarantee, no one can guarantee how good that is, because the way the soldering works, the quality of the components used, everything matters. In fact, if a short circuit occurs in the capacitor, it actually shorts the telephone line. That can cause an issue in the telephone line, and that are some issues that has to be expected. That is why these became bad over time. And there are actually a lot of reputable companies making these things, like T-Link, TP-Link, Huawei, etc. And those will cost you around 500 to 600 rupees. But people usually don't spend that much money on a simple device like this anyways. But and because they are expensive, they may have additional circuitry built in to protect the low frequencies from getting to the high frequency side also. But until I get one of those higher end devices to open and reverse engineer, I cannot make a comment on how that section works on such devices. But anyway, that's it for today. If you like this video, give this video a thumbs up, and let me know in the comments below if you like to see more of these tutorial kind of videos coming. Anyways, thanks for watching. See you in another video.